Hello, and welcome to my tutorial series on how to make a 2D platformer in Unity. In this video, we're going to add a little more polish and improvement to our jump. Let's begin. So the very first thing we're going to do is we're going to open up our player controller script, and we're going to reorganize some of the things we've done here, and you'll see as we go along why we did this. So we're actually going to reorganize some of our physics here and some of the things in our physics header, and we're gonna put them with our horizontal movement variables right here. And below this, we're actually gonna create a private float, and we're gonna call it horizontal direction. And now down here in our update, we're going to define this horizontal direction as get input and .x. Now down here, what we're going to do is we're going to create a function, and we're going to call this private vector 2, because this is the type of function it is. It's going to be named get input, and parentheses at the end, a brackets, and in here we're going to put this right here. We're going to cut it, Control V to paste. And instead of it just saying direction equals new vector 2, what we're going to actually write is we want to return a new vector 2. So all we really did is we took our vector 2 input right here, and we just moved it inside of this function right here. And the reason we did that is that later on, we're going to use this float in other if statements, and it's easier if we define it up here now rather than try to do that later or try to make it a more elongated way of doing things. So now that we've done that, we're just going to change up our move character a little bit. We're no longer going to be passing this float through, and we're going to go down here, and it's going to be rb.addForce new vector 2. No longer the dot right, and now it's going to say inside this parentheses right here like this, that it's going to be horizontal direction comma 0f for the y direction. And actually, we're going to get rid of this parentheses at the end. So we've just changed it up to rb.addForce new vector 2. In the x direction, it's going to be the horizontal direction, 0 in the y direction, and it's going to be multiplied by our move speed. And everything here is going to remain the same. And lastly, we're going to fix up this function. We're going to first off just change its name so it better reflects what the function is doing. So we're going to call this apply linear drag. Oops, didn't want that to happen. Put that right back there. And right here, everywhere where we have direction.x, we're going to change this to horizontal direction, just like so. And down here, and everything else will remain the same. And then going up here, let's just double check everything. And then we're going to go up here, and then we're going to need to change this. And then modify physics is now changed to apply linear drag. There we go. So let's just recap what we've done. So we consolidated our variables here under horizontal movement. Instead of our private vector 2, we created this private float we called horizontal direction. And the reason we did it is just to simplify some of the code we're using. So horizontal direction is going to be equal to this getInput.x, which is essentially, when we go down here, getInput is the vector 2 we were using. In fact, it should say return new vector 2, because when we have a void, it doesn't expect us to return anything, but this is not a void. We are expecting to return this vector 2 right here. So we just basically put in the get axis row horizontal and vertical movements that we put in previous videos. And then we have our move character and our fixed update. And don't forget, we are using fixed update because our move character uses physics. And so this right here actually should have a parentheses on the end, another error corrected. And so this is pretty much the same right here, and pretty much so is our old modified physics function, only we just changed it to apply linear drag because I feel that better describes what it's doing, and we just inputted our horizontal direction input in here also. So let's hit save and see how this all came out. No errors. Let's just go ahead and remember, we have two scripts here because I did the previous one, and I'll just leave that component there for now. But when you check this one, it means that this one is in use. If it's unchecked, that means it's not using that component. Here are our default values. Actually, we're gonna change these up. Let's change that to 20. Let's change that to 10. We'll leave the linear drag here. We'll adjust things later. We're gonna hit play, and nothing new here. We just changed up some of how our code works. Our movement is still pretty solid right there. As you can see, we have this little bit of a slide. As I said earlier, we can increase our drag and get much more tighter movements. You can play with that yourself and find the right amount of drag, acceleration, and max speed for your game. So let's get to work on finishing the code for our jump. Let's go into our player controller script. Let's create a new header and float. We're just going to copy these two lines right here. Control V, and instead of horizontal movement, we'll just put jump variables. And instead of move speed, we're just going to call this private float jump force. And we'll make it equal to 12F for now. And now down to our update function, we're going to put an if statement, if input get key code dot space, which is the same as we did before. And at the end, or inside our function, we're just simply going to, or inside our if statement, we're going to, it doesn't like me writing the word jump. There we go. We're going to simply make a jump function inside our if statement, and we're going to just have this function down here. Private void jump. And inside this jump function, we're going to put rb.velocity is going to equal to new vector 2, and this vector 2 is going to be rb.velocity.x, comma 0, 0f actually, it's a float. And this will just make our direction in the y direction 0. And then from there, we're going to add our force. RB add force. And that's going to be vector 2 dot up. And that's going to be multiplied by our jump force. And then force mode 2D dot impulse, which will make our movement in this direction instantaneous using the physics, and a semicolon at the end of that. Okay, a couple corrections here. Correct that little force mode right there. It looked like it had a capital O or a 0 there. That should be fine. And up here, for some reason, it keeps wanting to, or it wants to turn that into a function. Whenever I start typing it, we're going to hit save. Going to go back into Unity, hit play, and now our character can move, and now he can jump, and he has the eternal jump, which we'll fix in a second. So back in our player controller script, we're going to set up our Raycast, but it's going to be a little simpler than the way we did it before. So I'll just start off and I'll show you how this is working, but much of this will seem very, very familiar. So we're going to start off by creating a new header. And the header is just to organize ourselves. Actually, if you look over here, I don't know if I pointed this out before. I probably didn't. Is that the headers are just to make organization here in the inspector window. See, here's our horizontal movement, here's our jump variables, and it just keeps everything organized over here. Otherwise, all these variables would be bunched up here, and it might be a little difficult to read them. So that's all the headers are doing, really. So it's header, and inside we'll just call these layer mask. And below that, we're going to have a serialized field. Control C. Oops, that's not what we wanted to happen. And then down here, Control V. And this is not going to be a private float, though. This is going to be a layer mask. And this layer mask is going to be called, we'll just call it ground layer for now. And then we're going to create another header. Just do this all while we're right here. And this one will be for our collisions. So we'll just call these ground collision variables, because we're going to have wall collision variables. And our first serialized field here, well, actually this will be a serialized field. It'll be a, actually no, it will be a private float. And it'll be called ground Raycast length. And then underneath that, we'll have a private bool, and we'll call that on ground. So we just created some more variables up here, and now we're going to add in another function. We'll put that, actually we'll put these below our drag. We're just going to have private void check collisions. And then here we're going to have our Raycast on ground is going to equal, and this will mostly look familiar, physics 2D dot Raycast transform dot position times ground Raycast length, comma, vector2 dot down, comma, ground Raycast length. And then last, and this will be where it gets a little different, we'll have our ground layer. So in this one, it's very much, let's go back. We created, where is it? where's our check collisions here? Here it is. So last time we created some variables to punch in here with our 2D raycast, where we had the position and we had the vector 2 where it was going to be. These are the wall ones, actually. Let's go up to the ground ones, and a vector 2 dot down, and then ray length. And then this time our position, we're just dictating it by the transform dot position, which is the position of our player times the length of the raycast. Then we have our vector 2 dot down, our ground raycast length, and then this added ground layer, which we're going to also use to be able to check whether we're on the ground. So now we're going to put in the actual lines so we can see them, and this will be a little simpler also. Private void, we'll call it on draw gizmos, just kind of using a little bit of a shortcut. The last time when we did it in this script right here, we did it, let's get to the bottom where we had it, we kind of did it in a slightly longer way. This is a shortcut to using gizmos. So right here, we're going to put gizmos dot color is going to equal color with a capital C dot red, just like last time. The color is going to be red or whatever color you want to pick. And then we're going to put, oh, actually, wait, no, it autocorrect here, or whatever it is just filling in stuff for me again. It's not on draw gizmos, it's just gizmos. Gizmos dot color, and there's no this here. The filler is useful for some things, but sometimes it's not. So it's gizmos.color equals color.red, and then below that it's gizmos. There we go. Gizmos dot draw line, and then transform dot position, comma, transform dot position plus vector 3 dot down times ground raycast length. And then at the end of that should be a semicolon, and that looks good right there. All right, now we're going to go to the top, and in our jump variables, we're going to create a private bool, and we're going to call this one can jump. Oops, nope, we don't want that to be 2 words. And can jump, and there's a reason why we put this little arrow here. We're actually going to take this right here, and we're going to cut it out. And where's our Control V to paste? And we're going to say that the can jump bool is going to equal the input.getKey keycode space, pushing our spacebar button, and whether or not we're on the ground. And because we're using this other bool here, we have to use this operator right here, equals, and the greater than sign. If we just put equals, it'll give you an error. So then we're going to actually just get rid of that right there. And then right here, we're going to make sure to put in our check collisions function. And down here also, we're going to put if we can jump, then we're going to activate our jump function. All right, let's hit save. Let's go back into Unity, and let's go to our player, and let's make our raycast length. Let's try 1.3, and then we have to make our layer. So we're going to go up here. we're going to click on this. We're going to go down to add layer. We're going to simply call our layer ground. And now we're going to go over to our grid and our obstacle here. And we're going to label those the ground because that is the ground. That's the layer we want to mark. Go back to our player. And we have to fill in what ground layer we're talking about. That's the one we just created, ground layer. And right here we have our gizmo. And if you don't see it, you just click right here on gizmos. And it will appear and reappear. We're going to hit play. And we're going to move around. And there we go. Now it's jumping. So now it's going to jump around just like it did before. Okay, now things are working. All right, now that we have that reorganized, we're now going to go into the things that are going to improve our jump, just like the title of the video suggested, because right now all we did was really recode much of what we already accomplished in this other script. So now we're going to get down to making our jump a little better. So what we're going to do is first we're going to go up here to our jump variables. And we're going to add another serialized field. Control C, Control V, and then instead of jump force, we're going to have what I'm going to call our air linear drag. And we're going to make that, let's say for now, we'll do 2.5. And then down here in our fixed update, we're going to say if we are on ground, then we want to apply our linear drag. And then else, which is when we're in the air, we're going to, and we'll make this function a second, apply air linear drag. And then I'm going to go to the end of that. Okay, so then down here, where we have our apply linear drag, we're going to say private void. And then we're going to say apply air linear drag, which is the name of our function. At the end, some brackets, and then inside of this, we're going to say that rb.drag is going to equal air linear drag. So just to recap what we did here, if we're saying we're on the ground, which is just our regular drag, and then if we're in the air, we want to apply a different drag. We want the drag to change. We want maybe the drag to be a little different on the ground than in the air, and then we can apply those things right there. Far too much space there for one line of code. Create some separation between that and the other function, and we'll hit save. So now let's go back into Unity and take a look at this. And here is our air linear drag, and here's our regular drag, and here we are moving along. And you can see that, actually, let's increase this here. Let's change up these numbers. Let's make our air linear drag pretty high. Let's make our max speed pretty high. We'll leave this for now so we can play with it. So now I have my fast movement, and I can stop on a dime. When I jump, let's increase our jump too. Let's put a little beef on that. When I jump, I don't have very much drag here at 2.5, a little bit, but you can see if I increase it, I'll get a little bit of resistance as I jump up in that direction, giving me a little bit more control over how much I want to jump, how much I want my drag to jump. But let's put this back to 2.5. Another thing we have is we sort of have this floatiness to our jump still. Or I mean, not so much floatiness, but this kind of really wide range arcness to our jump. And if you really ever watch precision games, they kind of start out as an arc and then they drop immediately. And that's because they have what's called a a fall multiplier added to where if it reaches kind of the peak there, it will fall a little faster on the way down, and you'll see a very significant difference in how the controls feel and play when you have that sort of thing. So let's add that in. So back in our player controller script, we're going to go to our jump variables. We're going to add 2 more. Control C to copy, Control V to paste, Control V to paste, and we're going to change this first one right here. We're going to call fall multiplier. And we'll make it equal, let's just say 8F for now. And now the second one down here, we're going to call low jump fall multiplier, because when we hit our button, we're going to have 2 different jumps to go with it. So when we tap it, we have a little bit of a jump, and when we press down on it, we'll have a much bigger jump added to it. Jump, low jump fall multiplier. I should probably think of a much more convenient name than that, but it's too late. So we have the fall multiplier and the low jump fall multiplier, and down here into our else here where our apply linear drag is, we're gonna put a function we're gonna create called fall multiplier. And we'll make that function down here after our air linear drag. So private void fall multiplier, parentheses, and then we have our brackets, and inside here we're going to say that if our rb dot velocity dot y is less than 0, then what's going to happen is rb dot gravity scale is going to equal our fall multiplier. Then else if rb dot velocity dot y, actually, it says dot y down there, I didn't make a mistake, 0, and it's not input dot get key code dot space, and then rb dot gravity scale is going to equal to low jump fall multiplier. And lastly, else rb dot gravity scale is going to equal 1F. Maybe we'll change that later to 0. So basically is that we applied 2 different numbers up here, one a little stronger than the other, these fall multipliers. There's a fall multiplier and a low jump fall multiplier here. One's 8, one's 5. Maybe we'll adjust them a little bit when we get into Unity. But the idea is that if the rb.velocity.y is less than 0, then the gravity is going to equal to the fall multiplier. And then, just so we could read this a little better, else if the velocity in the y direction is greater than 0 and we're not hitting the space key, i.e. we just tapped it and we took our finger off, then the gravity scale equals the low jump fall multiplier, which is a little less, and if we're doing neither, the gravity scale will equal to 1. All right, again, it did this here where it filled in get input instead of input and it made it a function. So it could give me an error. So input.getKey, keycode.space. Let's see if anything else is wrong here. Oh, looks like the word multiplier is spelled wrong. Multiplier. Now it matches if your function is matching or if you call your function and it matches a function in there, it will be gold like this. Or actually mine is gold. I don't know how your Visual Studio works, but that's how mine works. Hopefully you have little hints like that to help you. And actually we're gonna go over here and we're gonna change that to 0 for our else. And up here in our apply linear drag function, we're gonna put rb.gravity scale is equal to 0. That way it always returns back to 0, our gravity, when we're on the ground. So we're gonna hit save there. We're gonna go in here, click on our player, go on game. And now you can see, go down here, that if I tap the jump button, it jumps a little. If I hold on to it, it has a great big jump. And I go down here a little, I go and I jump. I have sort of a nice arc, but then I come down a little quicker. I don't have that floatiness anymore, like I did earlier. So one last thing, there is an error in our code. This right here where it multiplies the position by this ground raycast length, that should actually be a raycast offset. So our character has more than one raycast here. He'll have 2 at each side. However, this video has gotten quite long, so I'm going to fix it first thing in the next video. You can go ahead and give it a try and see if you can fix it. That'd be great. As always, thank you for watching. Like this video, subscribe to my channel, follow me on Facebook and Twitter, and support me on Patreon. All links are in the description below. See you next time.